To go live. All right, hello.
Hey.
Hello, what's your name?
Hey, Peter Kafka, contract manager.
Peter Kafka, very nice to meet you. All right, so this is where you've been working. How long have you been working here on this contract now? You can keep on walking.
On this project, I guess I got involved about 5 years ago or 6.
5 years ago. So you saw some blueprints, you saw some drafts?
Before
like, hey,
the blueprints.
Before the blueprints?
Yes.
Like, we've got an idea. We want to build a new combined heat and power plant.
Well, that some other people had that idea. I guess I just got involved in it. I volunteered.
Great, and how has it been? What's it been like the past 5 years?
I guess it's been exciting, and that's all I can say. It's exciting. It's something new. You learn something every day, and something happens every day. You have issues, problems, so you have to solve them. So it's a non-stop. It's been non-stop for 3 years.
It's like life.
Oh, yeah, even better. No kids here, so it's a little bit better.
Ooh, okay, we're about to go in.
Let's go in.
All right.
So,
hello.
That's Jeremy. He's our safety officer.
Hello, Jeremy.
So, what would you like to know what we're doing here? So basically, I guess we're building a new, it's not a new power plant. We are adding a new boiler, a new turbine.
Because
we're expanding.
The last boilers and all of that infrastructure that's in the Atkinson building now
Correct.
has been there since the 60s, is that right?
Yeah, I think 67. Yeah, 60s.
And it's been going along, heating the university for 50 years, and that technology, anytime, could break down.
Well, I don't want to say it that way, but it's an old technology that requires a lot of maintenance. And it's not as reliable as the new technology.
And so that's why you got the money and you got the plans.
We got the money, we have plans, and this plant is more efficient and pollutes less.
Which is very important.
That's very important for campus and for everybody here.
Especially the philosophy of the university, which is studying climate change, the effects of man on the environment, so how to minimize the footprint of this small city that's on this hill.
And this new power plant will help.
So
when we shut down the old boilers, this plant will.
This is going to be the one. And when is that going to start?
Oh,
when are you pushing the button?
It's scheduled for November this year.
Do you get to push the button?
No, I don't. I don't know who's going to do it, but
you do all the work, but someone else gets the button pushing.
Too much pressure.
So this looks like you got some rail tracks.
So this facility where we are here, this building is a material handling building. That's where the coal comes in. So this boiler is it's fed with the coal. It's not a gas boiler. It's not an oil boiler. This is just a coal boiler. So, like the old plant, the coal comes here from Usability coal mine on the rails. So this is a grizzly. That's where we dump the coal to the basement.
So there's nothing, no coal has been dumped here yet?
No, this is still fresh.
All right, but they just come through, coal comes in, dumps down in there.
Yeah, one car comes in, we dump the coal down here and it goes down to the basement on a lot of conveyors. So if you want it, we can go down there and I'll show it.
That sounds fun. How much coal comes in every day? Is it like a daily, all the time, every hour?
We do it in the morning, about 100 tons.
100 tons?
You can go to the old power plant and see those coal cars sitting up there, dumping the coal in the morning. So it takes about half of a day to dump the coal that's needed for campus for 1 day.
For 1 day?
For 1 day. So here you see those conveyors. So the coal comes down here. Yeah, belt conveyor.
So that's where we just were, was right up there.
Yeah, we were just above.
And comes down in here, falls down on this, just a big conveyor
over
belt.
Here,
oh, it falls here.
And it goes that way. Ooh. So you can follow me.
We're there coal right now.
Alright. Comes over here. Dumps to another conveyor. Over here. It's like a bucket. Elevator. It's not a bucket. It's a high angle conveyor. So you can see those buckets here. That's where the coal goes in. And
so it comes through all the way down here.
Over here. So
down this way.
So it gets dumped to those buckets.
Oh.
You see it here?
Right in there.
It's kind of dark. But,
that's where the coal will live as it comes through here.
And then it goes up over here.
And it goes up here.
You see those buckets?
Mm-hmm.
So it goes all the way up to the...
So go ahead and shine that flashlight in there again.
Again?
So you can see right in there.
Right in there.
All right, great.
So it gets transported to the 4th floor.
So it's pretty nice and peaceful in here now.
No, it is.
But I'm assuming that if there was tons of coal
be cold, there'll be dust, there'll be noise. So it's a good time to enjoy it.
But it also feels, I mean, for people watching, it feels actually full of potential. It feels like it's waiting to fulfill its purpose.
Correct. And this is a nice feature. We call it a mist system. It's a dust suppression system.
Ah.
So when the coal comes in and they start unloading the coal, we create some dust. So this produces a nice fog, nice mist.
Just goes,
keeps the dust down.
That sounds like it's a pretty new. Do you have that over in the
No,
old
we don't
building?
have it at the old facility. And the reason is we don't have it because we unload the coal outside. You can't see it basically.
But through the windows.
So this all would freeze. It wouldn't work. This is a closed building. It's going to be heated. So this will work pretty good. And that's the idea.
So have you, was the mist system something that you were like, that's a great thing, we've got to have that? Or was that already in the plans? Or how involved were you with the designing of the actual?
This was part of the requirement for the pollution control. So it's part of the permit to have that, reduce that dust down. So there's no fugitive ash outside of the building.
I see.
So it's all one of those PM 2.5 requirements.
So important regulations to make sure that it's clean as it can be.
And we contain all the dust in the compound. Oh, my bad. I went the wrong way.
Oh.
I guess I can't multitask. So.
Just when you thought the stairs were over. No!
There's a lot of stairways.
So do you wear a fitness tracking device to find out how many steps you walk each day? Do you track that at all?
Not anymore. But we'll get you in shape in this 20 minutes.
That's great. That's good.
So, if I'm walking too fast, just let me
Oh,
know.
no.
This is just a warm-up stairway.
So that's been about 8 flights so far that we've done up here?
No. So this is still a material handling building.
Okay.
So that bell, the bucket conveyor you saw
Yes.
in the basement, it goes all the way up here. So you can see those guys.
Why does it have to come so far up?
So this comes up here. This equipment here, it's a metal separator.
Ooh.
If you have any chunks of metal in the coal, this removes it. It's like a big magnet.
Oh. So like electromagnetic spin.
Right. Catches all the metals and sends them over here. Inside.
Ooh. I see.
So that magnet catches them on belt. They stick to the belt and they get moved over here. They go to the chute. Those metal pieces, they go all the way down and we collect them in a bin.
Have you found some cool stuff? You got a little collection?
Not yet. We will. I can assure you we will. So, but the reason is, like, for example, at the coal mine, there's a heavy equipment that hauls the coal, digs it. So you have a bucket tees or something else, some metal bowls that will come with that coal over here. So that's where we try to catch all this stuff.
So it's just the coal that goes through after the material handling, which is the coal and all the other debris that might be in there.
Correct.
All gets cleaned out.
Or we pull the metals. If there's a wood, we're not going to catch it.
Oh, what happens if there's wood?
Well, it goes in the boiler and burns.
Oh, nice.
It's just like a coal, but early stage of coal, I guess.
Wow. Okay.
So that's what it is.
And this is also whirring and going and noise and all that stuff
Well,
happening?
it's going to be noisy, so maybe you should come back when we are running. Then you will see. You won't hear me probably.
I do right now, yes.
So this is like a surge bin. So we try to keep it full. It's just another smaller silo that we keep it full. So we're constantly feeding the crusher.
I think you said that's a smaller silo, but that's like 5 people big.
That's a tiny one.
That's a tiny one.
We'll show you bigger ones.
Okay, that sounds great.
So this one is a crusher. So it goes to the surge bin, and then it goes to the crusher. This reduces the size of the coal to the specific what's needed for the boiler.
How can you program it to be a certain
You can
size?
adjust. Those are the adjustable what do they call them? I forgot. But you can adjust whatever size you want for the boiler.
And so the coal comes in, and go ahead and do that again. So it just comes in there and then it just sort of mushes it?
No, it comes over
it?
here. For that, there's another like a conveyor goes here, and then it gets crashed to the specific size, whatever it's needed.
Crushed.
Yeah, there's a big rotating hammers, and it gets crashed.
That sounds scary.
It is, but simply saying that's what it is.
Yeah.
They're just crashing the coal to the smaller size.
And apparently they've been crushing coal since 1905. They know what they're doing when it comes to crushing coal.
I'm just trying to keep it simple so everybody understands what we're doing here.
So the coal comes in on the train, it's dropped off there. And where we saw it, it goes down in the buckets, it goes all the way up, a couple of floors up to where we are up there.
Metal separator, then goes to the
metal separator, then down
silo,
here in the silo,
crusher.
then to the crusher.
So after that, it goes to the big bucket elevator.
Over there.
Now it's a nice size coal, that's what we want to the boiler. It goes to this big bucket elevator. And this one goes all the way to the 9th floor.
Oh, so it goes up again?
Again, yes.
All right, the coal really gets
So now
over.
it's a clean coal, I mean, no metals in it, and the right size.
It's the right size and cleaned up and ready to burn.
Yes. It's like at home. You have logs of wood, then you split them to the right size, then you put them in a stove. Because they won't fit, the bit logs might not fit.
Right. You want them to burn nice and smooth. You want the fire to go all day.
Yes.
Or all night, depending.
So now, we are back on the main level. And I guess we should go to the 9th floor.
That sounds great.
So these are those bucket elevators. They go all the way up. You can't see it.
No, you can't really go all the way up, but you can imagine
Yep.
what it's like up there.
So, since we were walking here, this is the main floor. So this is the bottom of the boiler since we are here. But we'll come back.
That's the bottom of the boiler. The secret heart of the boiler.
No. It's just the bottom.
So when there's people working here, when it's up and running, are there people around here doing all the time, or is it just sort of an automated thing that happens? You just got to monitor the equipment?
Automated. We have a control room like we have at the old power plant. So when we're done, we'll have 2 control rooms. And people will be able to sit in one of them and watch both plants run.
And are you
control it.
Are you ready for virtual reality, where you put on your virtual reality headset and then in a 3D replicated version of the... No? Not quite yet.
Not like that, yeah.
More like Homer Simpson?
We have a simulator for the operators that will be working on it.
Oh.
We train on it. Also, when you speak about 3D model, we have a 3D model of this plant with all the structural and piping, so I could bring it on my iPad and walk with it and see if the pipes are in the right place.
Oh, interesting.
It's not 100%, exactly what you will see here, but it will give you a pretty good idea. The 3D models, I guess, over a year old.
So that's technology that's come even since this project has started.
Right. But that 3D was pretty helpful. When you were running some structural stuff, you can see where the pipes are, and you could find the conflicts. Like somebody said, the pipe's going to be here. Now we know we have a bracing, so we can run the pipe here. So that 3D model was very helpful. In the past, you look at the structural drawings, then you look at the electrical drawings, then you look at the mechanical drawings, and they're all 2D. So it's hard to imagine where they're going to be, the elevation of the pipes. So the 3D model helps a lot, just to visualize. Some people are good at it, and some people, they can't see it.
Right, I found that way like with Lego instructions.
True.
Like it looks all fine on that 2-dimensional piece of paper that comes in the box, but putting that kit together is different.
Well, I'm good at it because I have a 12 and 5-year-old. Okay, that's your 9th floor.
Woo! All right.
Whoa.
What a lovely view of campus.
So, the back of the elevator you saw?
Yeah.
That's this piece. 9th floor up. And then over here, if you look over up high, there's 2 of them. We'll use one at a time. So then you dump the coal over here to this conveyor. And you can see 1, 2, and 3 openings in the floor.
I see.
So we're standing above the big silos, coal silos. So that's how you fill up the silos. There's 3 of them. 1, 2, 3.
1, 2, and 3 done at the end.
Right. So we'll go down there. You'll see.
So it comes in, comes in from the train, drop down, goes up, gets cleaned out, gets crushed, gets sent all the way up here, comes down there, 1 chute at a time. You got 2 chutes ready to go. Comes in here, doom, 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 and then
1, 2, 3.
1, 2, 3, down into the big silo.
Yep. And then we're gonna go down.
All right. Should just call this the Adventure of Coal.
So you can see them down here.
That is a big.
Well, that's one of them.
That is enormous. Like if I try to get down here, I can. Okay, yeah.
They are big.
And this is just one, and there's 3.
There's one up there.
One over there.
2, and 3.
And are they full all day? Like, do they start out the day full, and then as the day goes on, they get used
full.
up?
I mean, they get used up, and we monitor the level of the coal, and the coal comes in, and we fill them up, and it's a daily operation.
It's just how that's what it's all about.
This is a penthouse of the boiler, since we are here.
Oh. The penthouse, you say?
Yes.
That's fancy.
It's
Have
pretty
some
fancy.
cocktails up here after hours?
No,
I don't
really,
think
not
the safety
exactly.
guy would like that.
We call it spaghetti piping here. So.
Because it's so flexible, or it just looks all noodly?
I guess it's new.
What is going on in there? There's a lot of.
So the water in the boiler. So the coal goes to the boiler, since we're not going to come back up here.
Right.
So I will try to explain to you. The coal goes to the boiler. It's like at home. You throw wood in the stove, you burn it. So we burn the coal, and then it boils the water in the pipes in the boiler. So basically, you're boiling the water, and then all this piping helps you to boil the water. And some of those wing walls, they call them superheaters. And then we have a steam drum on the other end. So the steam drum kind of separates from water to steam. And then superheaters, they take that steam from the steam drum and they superheat that steam. So they make it a dry steam. And that's the product we send to the turbine.
So when we see the stack, a plume coming out of there, that's not smoke.
It depends what stack you're looking at.
Oh, okay. So is there a steam stack and a smoke stack and all of that sort of
No,
stuff?
there's some vents on the
Okay.
building, so they constantly vent, so you can see some steam. Whatever you see on the building, that's probably steam.
Steam.
Most of it. But on the stack, that's just the exhaust from the burning process. So
it comes in there just like a house, heats up the
Yeah.
water.
basically, that's what it is. It's like a kettle. But we were not looking for the hot water. We were looking for that steam that escapes.
Ah, because the steam has the energy that can push things and make
So
things
you see that
go.
steam, like if you boil water at home, you see that steam. So we call it wet steam, because those are basically small droplets of water. Then we superheat it, and we call it dry steam. You can't see it. So if this pipe, so to give you a perspective, this whole building, material handling and the turbine building, is just to produce that steam in that 12-inch pipe.
That's going into here.
Yeah, so all this just to have steam in this pipe. And so if this pipe was made from glass, you wouldn't see the steam in it.
It would just look transparent as
Yeah.
it was going through there.
So that's wet steam, you would see it like a fog. That's basically...
So it hasn't been used yet. No steam.
No, it hasn't been used.
So that's pretty
You're
exciting.
getting-
I'm touching something. So far, has not done anything except just be here and look beautiful. It's nice little wrapping on
Yeah,
here.
it's nice and clean and nothing leaks.
Nothing. Yeah, it's all great, and it's going to work perfectly.
Oh yeah,
Of course, it's been well planned.
of course.
So it's steam, and so there's steam tunnels all throughout the campus. Is that how it gets? So the steam from here has to be pumped, like up to West Ridge and
This is high
stuff.
pressure steam. So we have to reduce it to low pressure steam. So we go from 600 to 600 psi to 30 psi. and that's what goes on campus. But that happens later.
That happens later. Oh,
Later, not here. This steam goes to the turbine to produce power for campus.
I see.
So we make 600 psi steam at 700 degrees, and we send it to the turbine that will go out there in a minute. And it spins the turbine spins the generator, and we produce power. And that's what we send on campus. That's where we get our power from. Now that's what's happening at the old plant.
Right now.
Right now, but now we have a bigger turbine. So this turbine will be capable of providing about 17 megawatts. The one at the power plant, it's up to, I guess, 10 megawatts.
More power.
More power. So our peak is about 13 megawatts need for electricity, so we buy the difference from Golden Valley.
I see.
But when this is done, we don't have to buy anything.
Self-sufficient.
Self-sufficient. That's the idea.
Look at
So
this.
that's the steam drum. That's what I call the steam drum.
What do other people call it? You just call it the steam
I guess
drum.
we all call it steam drum.
That's right.
the technical. So that's what separates the hot water and steam.
So it's a drum not because it makes a music. It's just because it's a big hollow thing.
I guess you can make some music here, but that's what it is. And this is connected to the mud drum, which is 2 stories down. But that drum is full of water.
And dirt, I'm assuming because it's called the mud drum.
Yeah, I wish we could go look inside. Now, boiler is full of water.
Oh.
We have it at, I guess, 200 psi pressure. You can look at it. We hydro tested it yesterday, the boiler again, to check some welds we did. We found a small leak in the plug. We tightened up the plug.
Sort that right out.
We're going to hydro test it again today.
So test, fix, maintain, test, test, test.
We've done a major test. It passed. We had the inspector here, and it all passed. This is just another test. We wanted to assure that we did a small fix on the piping in the penthouse, that this doesn't leak. So this doesn't leak, but we found another leak on a small threaded plug, like a 3/4 inch, and they are working on it as we speak.
I'm assuming that's a point of pride for you and the people who work here, is to make sure that there's no leaks, it stays nice and clean, it works smoothly, it works efficiently.
That's part of our quality assurance program. But there's always something probably that's going to get missed, but we are doing our best. And, I think we're doing a pretty good job here.
You got a whole team working on just that.
Yeah, there's a lot of people. At some point we had about 250 people on site. Just working here now.
Assurance from the off-camera advisor. Great.
So this is the top of the building, the top of the boiler, top of the building. That's where we are now. So
Let's
now
go look out the window here so you can sort of see a view that we're not quite at the tippy top because there's a whole, but look at that.
So you have a look at the old plant. You see that railroad car?
Mm-hmm. Right down there.
So your question was, there's the new plant, old plant.
Yeah.
We're connected. You see that bridge over here?
This one right here?
Yes.
Yep. Mm-hmm.
So there's a steam line in it, condensate line, water. So we can send steam to the plant and run this turbine, or if this boiler is out, the other 2 boilers that will remain can send steam here to run this turbine. So we can work either way.
So it's not like that's not going to be torn down. It's going to stay there and keep on doing stuff.
There's 2 boilers in it, those 2 old coal boilers. As soon as this one is working and is approved, we're going to shut them down. That's by permit. That's a requirement.
Give them a little rest.
Yeah.
You're going to have a ceremony for it? You've done your job, boilers.
Yeah, 70 years.
70 years and counting. Yep. All right, so that's the top.
That's the top.
It's just a hint of what the noise will be like.
Yeah, we're coming. Now it's easy. We're going down. There's not much on the 8th floor to see. Just to see the boiler. Basically.
But I'm assuming you have to have access to all the places along.
We do
case
have it.
anything goes on, you can just walk right in and take care of all that stuff.
Yeah, not to the boiler necessarily, but we can access the boiler at a few locations, and if needed, we can use like a hoist, or we call it sky climber, that we're gonna install, and you can go to any level in the boiler to look at the pipe.
You can get out there on the roof.
Not much on this floor.
I would say it's deceptively quiet. I'm sure there's a lot that happens here. We just
Correct.
Just no.
Probably not on this.
Just not on this floor. 8th floor. Okay, so here's a question. Why no elevator?
There is an elevator.
Oh, there is an elevator. Okay, great.
There is an elevator.
But for the tour, we need
But
to
only
see.
one guy has a key.
I see.
Because everybody would be using it.
Right, right, right.
So we're on the 7th floor. You see those heat exchangers? This is part of the HVAC system for the building. So this is not a process thing.
This is for here.
This is just for heating the building, keep everybody comfortable. And also preheating the combustion air that goes to the boiler. So if you stack the -40 air in, you want to preheat it a little bit, warm it up. And then it goes through the economizer, and air preheater goes to the boiler. So.
And even right now, there's signs saying that tests are happening right now inside some of these
So
things.
a lot
So
of
all of this is going
equipment
on.
here has been tested and it's energized. So they don't want anybody, for example, to go in and the fan starts automatically.
That's dangerous.
It could be dangerous.
So all of this is still, it's so, thank you so much for the chance to come and just see everything like ready to go. Like it's like Christmas morning. I got some water stashed.
You want some water?
Oh, sure, I'll tuck one right here in my,
Arlene, you want some water?
thank you very much. There's a lot of walking around that goes on here. Oh, look, here are these, so the stickers.
Yeah, the labels.
The labels.
Somebody's working on labels, you can see over here. So there's so many piping and they all look alike. For the new people without the labels, they wouldn't know what it is.
Right.
For us, we've been here for years, I guess. I can say it, we've been here for years.
You've been here for years.
So we basically know every pipe here.
But eventually a new generation of workers will come in.
Oh, basically the personnel from the power plant will come over.
Will come
here.
over.
So they will run this plant. They have to learn how it works, and it's going to be a process.
They've got the simulator and stuff, but there's nothing like actually being here.
No. So
Are the labels like they're, you don't just print them yourselves? It's like there's a standard for
there's
labels?
a standard, the contractor works on them, and basically they're the same color. It's just the specification for it, how we're going to label it, the distance between the labels, for example. So you don't want to put one label here and nothing in the next 100 feet because there's too many pipes here, and people will get lost. So this is still the coal silo.
So we saw the top of the silo
This is
up
the middle
there,
section.
and this is the middle section of the silo. Still will be full of coal. So all day the coal fills up, it sort of drains
Gets
out
used,
because it gets used, and then it gets refilled each day. And there's 3, 1, 2, and then there's the third one down there.
I'm not saying full, but you don't want to have a low level in them because let's say something happens on the Alaska Railroad, then you want to have that safety, that cushion in there.
I see. So you got to make sure you have your supply.
Yes.
You have a secret coal stash, like the good stuff that you just bring out in case of emergency.
But I think in case of emergency, let's say the railroad tracks are washed out or something, I think the plan B is to bring them on the trucks. So they can drive the truck through that material handling. You saw it was all paved. So they can bring the trucks and dump it with the belly dumps or something.
So they can still
there's
get
a
the
plan
stuff
B.
here. Because when the university is in session, even now in the summertime, there's people here all the time, 24/7. Need to have energy, need to have, especially when it gets cold. So this needs to be going all the time.
Correct. So power, we need power for all the computers and anything else. Basically, it's mostly the computers, lights, and whatever else people use power for. There's a lot of electrical chillers up there on campus.
Labs and the coolers to keep
Fans
samples.
and everything. Then we send some steam because they need them for lab. Then we produce a compressed air here. They need it. Then we produce RO water for the labs. So basically, we provide everything they need on campus.
Hello.
Oh, we're part of the video now.
Yeah, you sure are.
So here we are, and this is the bottom of the coal silo. So that will give you a perspective how big they are.
So they start out huge. The coal's been in the crush to the right size.
Yes.
It comes all down through here.
And there's a valve, there's a shadow valve, so you can either close it, and let's say you don't use that one because you have to work on another conveyor, the
So you
feeder.
can just turn this one off,
Correct.
and then you got that one over there, or
that
that one over there.
So that's why you need those shuttle valves so you can do the maintenance downstream of that. side.
And look at these bolts. Like, is there a big wrench? Did you use a machine? Like, does a human just, your finger tighten
Yeah, they
them
have
so
big
they'll be good to
wrenches.
go?
They have pneumatic tools, so whatever works for them. Well, yeah, that's more like a racing car. So.
So I think the wrapping on the hammer, it's like Thor's hammer, just sitting here waiting.
Yeah.
But Thor, he who is worthy will work on the CHP. Do you have a pet name for the building that you're calling it yet?
No, not yet. I guess early we have to do it something like this in the office.
Maybe open it up to the public and you get Building McBuildingson or something like that.
Like a nickname for this.
Yeah, a nickname. Well, I won't start anything. I don't want to have people commenting on the
I'm
video.
sure there'll be an official name for it, but
Yes, but you can have your own pet name.
So we're on the 4th floor, so I can maybe show you something here.
Look at all this still relatively clean grading. Wrapping.
Over here. So remember I told you we hydro tested the boiler
Yeah.
and we found a small leak. So you see that plug up there? We stripped some insulation this morning, so that's where it was leaking. So they're gonna tighten it up. We're gonna test it again.
So a leak right there. It's kind of out of the way, you can say. Did you have someone down here watching? Or?
So when we do the hydro test, we put it up to 800,000 pounds. And then we walk the boiler down, we check all the locations, valves, and we look for leaks.
And you find
Then
one
also
here.
there is somebody watching the gauge. If they see, the pressure is dropping, then we know, something is happening. So everybody's on alert, and we're trying to find them. That's all you can do.
That's what you want with the testing you wanted before, like it's critical.
Correct.
So this is like a big thing, but just a little support down here. Watch out for that pin. Don't pull that pin. That holds the boiler.
Not only that thing.
That's an important part of it, though.
Boiler or air ducting? Let me look. No, it's just for the air.
Oh, so it's holding that down there.
Oh, basically, I should have mentioned something when we were on the
Oh.
ninth floor. This whole boiler is suspended from the ceiling. It doesn't sit on the floor. It hangs off the ceiling.
That's interesting.
So when you start the boiler, it heats up and it grows.
Ah.
Metal grows when you heat it up. So instead of sitting and growing against the gravity, it just hangs and grows down.
Like a stalactite. It just sort of
It
expands
grows down
downward.
with the gravity. So
That's interesting. So coal technology has been around for centuries
I
for
guess
humans.
so.
But this is all sort of new thing that they're adapting, learning how to make it work a little bit better, more
Well, I mean,
efficiently.
this technology is probably like 30 years old or more, but it's still new. It gets updated. They come up with the new features, so it's constantly growing.
Someone's like, what if we hang the boiler from the
Somebody had that
ceiling?
idea. And
Now here
it
it is
worked.
in Fairbanks, Alaska.
No, they have them on some other places too.
No, it was here first.
No, this wasn't here first.
Well, you want it proven. You want it proven.
Yeah,
You
we don't want to experiment here.
Yeah, that's what the engineering
People
building is
have
for.
done it before, and then
Yeah,
I guess
so
it didn't work. So
that's it.
those are the gravimetric feeders. So silo coal comes down here, and we feed it to the boiler.
It goes right in,
Actually down.
Down.
On the next floor, you will see it when it goes.
and that's in the boiler stuff. So the boiler might be inside there right now.
This is
Starts
all
in-
boiler.
This is it right here.
Watch out.
Gracious, thank you.
What's your step?
All right,
So this
it's
is-
a wall of
this whole-
steel.
This whole box basically goes from the first floor to the ninth floor, and we call it the fire box. That's where the fire is. So the tubes here are on the outside walls. We call them screen tubes. That's what it gets heated up first.
I know last week they did some flame testing, and I wasn't able to come down. I had another appointment, and they had the fire marshal was down here, and the fire department making sure they could turn on all the flames.
So we were doing with fire marshal. We did last week. We did this sprinkler system inspection, which you see the stem pipe is part of it. And then a few days later, we did the fire alarm system inspection. So you probably heard some noises and strobes, and that's what we did.
So I saw like a QR code. Hello.
How you doing?
I saw a QR code posted. So you walk around with the tablet and scan the thing where you are to make sure how things are going? Is that the sort of how that works, or?
That will be for the maintenance.
Okay.
So they can scan an equipment, and it goes to their PM system, and they know what equipment it is, and it's for the maintenance purposes. So it creates a database, basically. So here on this floor, you have burners. We call them, guns.
Mm-hmm.
So that's how you start up the boiler. So you run the oil to the gun or gas, either one. And you start up the boiler. So you warm it up. You create you raise the temperature up, and then you start dumping the coal to it. Coal starts catching on fire, and that's where you stop those guys, and then use just the air and coal.
To heat the water.
To heat the water. I mean,
the water boils,
yes.
and you get the steam. You get the wet steam, then you get the dry steam.
Dry steam.
Send the dry steam out.
To the steam generator.
That is amazing. But this is really where it starts. Like if there was a button to push.
It's in the control room.
I'm still looking for that big red button.
Yeah. And there's no one single button like push it and walk away.
Oh, there's
like a sequence they have to work. Open the valve. There'll be guys here. Open the manual valves.
Go valve 2. Valve 2, go.
Yeah.
Go valve 3. We're ready.
Yeah, John, where are you? Yeah. But there's a lot of manual valves, so you have to open up manual. So not everything is automatic. Like you push it, you walk away. It doesn't work. It's not like you make a soup. You push it, you put everything in, and you walk away.
And then you come back, delicious for dinner. No.
Yeah.
No, it doesn't work quite that way.
So we have one on each side, basically.
The guns.
The guns. That's what we call them.
All right. Look, it's the secret elevator. This one's even.
That's the.
You can't even go in there.
See, it's in use.
Yeah, that's very safe.
That's the key.
The plastic is still on the door.
It's
Okay.
I've never used it.
Who needs it? Elevators, schmelevator.
I guess. I wish we had it a year ago, but now I'm used to it.
Yeah.
So all this big ducting you see here, we call it a primary air and secondary air. So it all goes to the boiler. Primary air goes at the bottom of the boiler, you will see it, and the secondary air comes over here. And I think, I'm not an operator, but they will have to balance it, how much air goes here and at the bottom to see the temperatures in the boiler, the pressure. So it's all balancing, depends on the load. Hey! So that's how it works.
So it's there's constant monitoring to do.
Correct.
Just making sure that the mix stays right.
We have a lot of temperature sensors, pressure sensors on the boiler. We're constantly monitoring what's where. And that goes to the automatic system. Software works on it. There's a DCS system. There's logic for it. And so we have
that's fun over there.
Oh, that's fun.
Something's happening.
Water's coming out. I don't know.
I guess it rained something.
Well, they're shooting a music video.
Maybe I should go upstairs and see what's going on.
You want to take a little break?
If you want it.
Or I can come with you, whichever you want.
I'm gonna go upstairs.
Okay. All right, we'll come back with part 2.